Hey guys, thanks for tuning in. Today we're going to unbox, build, and do the initial prints on the Ortur 4. Alright, so this has a strange build volume. It's 260 by 210 by 305. And from first glance, it looks strikingly similar to the baby Sidewinder. Earlier we showed the Sidewinder X1. There's kind of a baby brother version of that, and this reminds me quite a bit of that guy. So in this bag, we have some assembly bits and the manual. I'm gonna have to give that a good look over. I'm not entirely sure what this is. It looks like the top of the gantry where the lead screws are gonna go into these. Power cord, some sample snips. And they're using styrofoam instead of the kind of puffed black foam kind of stuff. I think that's a spool holder, we'll find out. And then the more impressive pieces. So here is the base. It comes mostly assembled, so we'll really just have to attach the uprights for the most part. It's quite a high box for the base where all the electronics are. So we've got the build plate, and they've opted for a proper nylon cable chain on both the Z and the Y. I'm not sure if the X has it as well. And I think, yeah, there's this protective plastic just on here that we'll have to take off. They've given us this little sticker sheet with some 3M adhesive to go on there. So these are linear guides, and I believe these are the uprights. Lead screws. Yeah, so here is the X-axis assembly with that nylon cable chain as well. Yeah, so X, Y, and Z all have the nylon cable chains. There we go. So this bracket here has the filament runout sensor. It's got the two threaded coupler things for the lead screws to go through, and then the extruder, of course. And that is it. So as I kind of mentioned as I unboxed some of this stuff, there are cable chains on X, Y, and Z, so all the wires are nice and neat and tidy. And it makes sure that you're not going to have a strain break in the wire if it's being bent in one spot over and over. And that's one of the reasons we add strain relief at the very least to the bed, for example. But the Y is also linear rails and the Z is linear rails. The X is also linear rails. So we don't have any V wheels here at all, which is kind of nice on one side because the V wheels need to be replaced over time and they kind of dust that little stuff. But on the other side, adjusting them is a little bit trickier. So first things first, let's take the top bar here, and this would be the rear of the printer. This is where the Z lead screws are going to go in. And we are going to bolt on the filament holder. There are offset holes, so it only goes on one way like that. And there are M4 by 6mm bolts in this bag here. So these little short ones, and we'll just thread 3 of those in there. All right, so we have a filament holder. So the uprights, one of them has this little flag. This is like your Z-min switch trigger. Instead of having a micro switch here, there's going to be an IR sensor on the gantry that travels down. And then when this kind of breaks that IR, it knows that it's at the bottom. This switch is going to, or this flag rather, is going to go on the left-hand side if you're facing the front of the printer. And we know that because these tapped holes line up with the holes in the side of the base right there. And then that leaves this one, again, with tapped holes here. Has to go in this way, like that. So to bolt these on, we're gonna use more M4 by 6mm screws from that same bag. And there's just 2 in each side. You might have to wiggle it around a little bit to make everything line up. So there's a little bit of play in these bolt holes. So you'll want to make sure that this is square. Ideally, I would take like a machinist square or something similar to make sure that this is perpendicular to the base. Okay. And this kind of a setup is nice where they just fall into these little holes, because normally you're balancing it on top, and I usually lay it off the end of the table and bolt in from underneath. This is a much easier way of assembling this, that's for sure. All right. So now for the x-axis here, if we flip it around and look at the back, on the back here, using M4 by 10 bolts, which are the medium-ish ones here, we need to bolt this back plate onto there. So these kind of act as standoffs, and they're going to bolt through the holes on the back here. And this needs to be this way, yeah, so that the stepper motor is furthest away from this back plate, like that. And then I'll just bolt on those 4 bolts. So I did have a little bit of an issue. These 2 bolted in fine. This one lined up, and this one didn't line up at all with that large standoff on the back. The standoff was on an angle like this. Now that standoff is bolted to, excuse all this mess here, is bolted to this assembly here, and this assembly is attached to this rail with 2 screws. These 2 screws, if you loosen them, this entire bracket can kind of pivot a little bit, and that pivoting will bring that standoff more in line. It will kind of tip the whole standoff assembly because it's attached to that same bracket. So I left those a little bit loose so that I could line these all up, get those bolted on, and then tighten those back again. Looking more closely at the front, you could see that this side of the rail here, the side of the X rail, was cockeyed, was definitely not kind of perpendicular to the Z. So now that's a lot more squared up. It's probably not perfect, but at least I can continue assembly. So now we're gonna add the X-axis onto the Z uprights, and we basically just thread it down from the top in this groove. Inside the ends here, you'll see 3 wheels. One is offset from the other 2. That will allow you to properly tension them against the inside of the rails. And again, on this side, down in here. So those are the 2 areas that we're kind of threading on. And just be careful of all the wiring, especially on the stepper motor side here. There we go. It's a pretty tight fit. There. And there. All right. Feels nice and smooth. And there's definitely tension on there. And I think we have to, if I'm not mistaken, I don't think we can change that offset of the wheel without taking this entire thing off. So hopefully we don't have to do that. So the instructions say to use an M3 by 6mm screw to attach the cable chain to the side of the upright here. So that's what that threaded hole is for. And you would screw through one of these holes here. So that would end up pinched there like that. However, unless I somehow lost it, there is no M3 by 6 screw in here. So we're gonna get one from our bin of spare parts. And then both of these cables here end up just plugging into the side of the unit, and they're keyed, so they can only go in one orientation. like that. And then there is a cover for that. And so you can kind of tuck those wires out that little outlet. This does go only in one orientation, so this little ribbed section is going to go where the cutout is for the wires, like that. Great. So that gives it a rather nice finished look. All right, let's turn the unit around. We're gonna add the Z-axis lead screws through these threaded couplers there. So these should just slide right down through the brass coupler and into the coupler at the bottom. Sorry, the threaded insert, not brass coupler. Bottom them out in the coupler, and then there should be a couple screws on each coupler to secure them to the lead screw, to clamp them on. There we go. Okay. So down here, yeah, the bottom one's already tightened. That one's holding it onto the stepper motor. The top one here will clamp that on so that it's pinching the lead screw. Okay. While we're here at the back, we may as well connect these. So one is for the extruder stepper motor there, and the other is for the filament runout sensor, which plugs in the bottom here. Okay. And then this, so this is the Bowden tube that's going to connect to the extruder, and it screws in on this side. So our filament's going to come down through here, runout sensor into there, and then to the hot end. The hot end is, at least visually, reminiscent of what we saw on the TiVo Flash, and more recently on the TiVo Tarantula Pro. There's dual cooling fans, one on either side. In this case, they're not using a Volcano style hot end. Just from appearances, it's like an MK8, kind of. I'll have to confirm that. And we do have auto bed leveling. It's using an inductive probe, which is at the back of the hot end there, right behind the nozzle. There's an entire page in the manual here specifically about bed leveling. And one thing that they mentioned that a lot of people still don't seem to realize is auto bed leveling doesn't mean your bed can be completely out of whack and that it will fix that for you. You still need to have a level bed. It's to get you that extra kind of 10% there, just to take into account any warp or any slight out of alignment in your manual leveling and correct that for you. So I think we can put on the top piece here. As I mentioned before, the lead screws are going to go into these two little fittings. So this is going to go like that. And then there's a hole in the top, and that would be for our last screws, these long ones. So now I think we'll plug it in, turn it on, and just make sure that everything seems to be working. And we'll take a look at the screen there. Okay, so standard Marlin kind of menu. If I go to motion, so I can home the individual axes separately, which is what I would actually like to do. So I'm gonna home the X, that works. Home the Y. So before I go auto homing, I just wanna take a second and address the little blocks that came with it. These blocks, you're to put under the ends of the X-axis to make sure that it's of equal height on both sides. And so manually with your hands, you're going to turn those couplers that are attached to the Z lead screws. You want to make sure that either the printer is off or you go to motion and then disable the steppers so that they're not kind of locked on you. So I've positioned the blocks so that they're resting on the opposite side of this rail and they're not obviously touching the belt. And the other side here is firmly against the block, and this block obviously has a lot of space. I can't lower this any further because there's actually some tension. You can tell that this X rail is not completely perpendicular. I'd mentioned these earlier when I was trying to bolt in this back plate that I had to loosen these to allow the standoffs to line up. And I knew that we'd have to double check it for square. So if I loosen that, I may need to do the other side as well so that it's kind of floating. So by loosening all 4 of those bolts, I'm able to line it up so that it's resting firmly on both of the blocks. This side might need to go up a little bit. And then tighten these all back down. So now we're done with these blocks. We've leveled the x-axis, and we can go to motion and then auto home. Now this actually ends up homing the nozzle completely off the corner of the bed, which is great. We don't have to worry about the nozzle diving into the bed if the bed is too high. Normally you'd want to pre-tension the corners a bunch to bring the bed further down to give you enough clearance to make sure that that doesn't happen. In the menu, in some versions of Marlin, depending on how you configure it, under the the motion menu here, you'll have bed leveling, and there's an option for level corners, and that will kind of jump you to the 4 corners and optionally the center to do your paper drag leveling. In this case, they just suggest that we disable the steppers. So go back to motion, disable the steppers. This will allow us to freely slide the X and Y around by hand, and then we'll do the normal corner leveling with the paper. You want to do this all up to temperature. So let's go to temperature, and then we'll preheat it for PLA. Great, now we're up to temperature. We still have the steppers disabled. So let's see if we have any drag. Let's rip this to a smaller piece of paper. There is likely going to be a little bit of filament oozing out the nozzle at this time from the test at the factory. So you want to make sure that that's cleared and not affecting your dragging. Wow, we had lots of clearance there. You may notice at the top here you see this little light go on. That is the probe sensing the bed. We'll need to tighten down this other corner here before we move over. The x-axis feels extremely stiff, so I'm hoping it either kind of loosens itself up, or I may need to take a look at the tension on those wheels that are running in the linear guide. As I'm moving it front to back, I was keeping the paper underneath it just to make sure that we don't end up gouging the bed with the nozzle, and the nozzle was too tight, so I'm glad I did that. There we go. And then moving it over here, I'm just going to tension this corner first. There we go. Okay, so I've gone around once. I'm going to go around at least one more time and double check each corner. They all have an equal amount of drag. Okay, I'm just going to double check in the center here. So it's a little low in the center, but that's what the ABL will help us with. Okay, be careful when moving the bed around like that. It is rather hot, 60 degrees or so. So now, if we go back to motion and we go to bed leveling, we'll hit level bed. And this is going to do the ABL probing sequence. And you can optionally kick this off at the beginning of every one of your prints. In your start G code, you could add a G29 with no other parameters, and that will just kick off the default bed leveling that it's got in the firmware. Optionally though, if we've done this and saved the mesh that this builds, we can call it up with an M420S1 instead of having to do another probe sequence and save ourselves a little bit of time. But honestly, in my case, I just leave G29 in my start to G code and let it do this before I reprint, just as a double check. So the bed leveling's done. You can now see that bed leveling is on, and we'll want to store that. It's interesting that the fade height is 0. Fade it over 2. Store that. Okay. Let's get right out. So it's got no SD card. Let's throw an SD card in. So I didn't mention it, but it comes with a nice trans flash adapter, so a USB stick where you can throw the TF card or the micro SD card into it and into your laptop or computer. And that goes in the left side of the machine here. Let's take a look at what models they've provided us for some test prints. I have no idea what any of these are. So let's go through one by one and print them off. All right, we're back with the Ortur 4, and I've done some test prints. This was one of the pre-sliced models off the SD card, and this is something that I sliced up. What's interesting is when I sliced it, obviously I used a G29 because we do have a bed leveling sensor on here. That does a 4 or 5 by 5 probe of the bed, and it worked beautifully. I got perfect first layer, I didn't have to adjust anything, but I did notice that it was quite violent. It was shaking the very large table that I have it on, almost like a dining room table, and it was shaking that thing, and as a result, we have some ringing here as it comes out from the Y, for example. There's some ringing, so you've got ghosting of the Y on the side. The X is not nearly as bad. There's a little bit of ghosting on the X also. The top layer turned out extremely jagged. I'm using a very similar profile to what I would use on a CR10, or even you can just take the base Cura profile for something like a CR10 as well. I use 6mm retract. I use 0.48mm wide layer lines, which is kind of standard, 1.2 times your nozzle size or so. And yeah, it just turned out extremely rough. This material is a silk PLA. We do it about 190. This was another color of the same silk PLA done on their slice at 190. The temperature's definitely right on, especially considering that this is completely hollow, so there's a lot of bridging involved here. So just generally, I'm not super happy with well, number one, the acceleration values that they have stock in the firmware, because I don't control those in my slicer, and the jerk values that they have. So when you turn on the machine, the jerk was set to 15, but if you run another one of their prints, it had the jerk set as high as 30. So when that's set the jerk to 30 and then the print is finished, I look at the jerk values on the screen and they're still set to 30. So now if I run another print where I don't set the jerk values, I'm inheriting the 30 jerk, which is just obscene. So even 15 is high. I would definitely not run it higher than 10 normally. And the acceleration values, I think they were as high as 3,500. So very, very aggressive values, if you will. Now this particular slice, the jerk was set to 5. Which would be on the low end of the scale. And it was very smooth in its movements. It turned out great. The cooling worked very well. It is cooling from both sides. And yeah, this is, aside from about a 1mm thick outer wall, just over 1mm, it's completely hollow. So like the top of this fin here was just bridging over largely nothing. Granted, they do have quite a few layers there so that it could build up and flatten itself out, but it worked great. And honestly, the finish turned out pretty good. They definitely could work on their Z seam, so there's no coaster wipe really to try to help blur this. And really, because there's no sharp angles, not like a cube, we can't line them up on a sharp corner or anything to try to hide that seam. Likewise, down here at the bottom, you can see the seam a lot. But generally, it turned out fine. I don't see any kind of moire pattern. They are using noisy drivers, if you will. I don't know exactly what drivers, maybe it's A4988s, but it's definitely not silent. But unlike some other printers we've reviewed, you don't have that artifact pattern showing up. There's a little bit of ringing, mostly in the y-axis, which is not surprising. On the sides, which would be the X moving from side to side and stopping, we don't really have the ringing that we have on the front and back of the print. But I'm generally happy with the construction of the machine. I really do like the linear guides, especially considering over time they should be more maintenance-free. There are some design choices that I'm not a huge fan of. I do like proper nylon cable chains, but like they have a vent in the bottom of the unit, or the top of the unit here, sorry. But as you know, it was doing ABL probes, and we have little pieces of plastic here. They get knocked off the bed, and the next thing you know, they're down inside your control box. I'm sure there's a fan in there, then they get caught in the fan, et cetera, et cetera. So it's kind of hard to keep that clean, but I think they're using it just to kind of let the warm air from inside the case draft out, more or less. They did have a lot of the menus exposed in Marlin, which is nice to see. I wish more manufacturers would do that, including rapidly double pressing the button to invoke, in their case, the Z offset, which is great. So if you set your Z offset for the probe and it's not quite right while your first layer is going around, maybe your perimeter, you can double press and adjust that in like 0.02 millimeter increments, some very small amount anyway, until you have it set to exactly the perfect layer, and then store that value. So that was nice to see. On one of my prints, it was too close, one of my first prints. I was using ABL, unlike this one, so I was able to rapidly adjust without having to stop the print, adjust that, and then restart the print, so that was nice. I do like the cable management aspect of things. The spool holder works well. I'm glad they at least included one, let's put it that way. And generally, like all around, the construction is very good. It feels like a solid machine. It's definitely heavy, if that matters to you, but it's got some heft to it, that's for sure. The build surface, I was skeptical. It works, at least for PLA, it works very well. I was using the heated build plate at about 55 degrees for my prints. They stuck like glue. And then the moment it cooled to just above room temperature, I was able to just kind of grab it and pry it off without any kind of tool. I'm not sure how other materials would work. Maybe PETG would have a little more difficulty, or even bond completely to it. I'm not sure. But at the very least for PLA, it's more than adequate. And the build surface itself is surprisingly flat. So that also helps, though you do have that built-in ABL to compensate if the need arises. So hopefully my ramblings there were useful to you. Remember to like and subscribe and ring that bell to get notified when we upload more videos like the Ortur 4. Thanks for watching.